What's going on, everyone? In today's video, we're going to be talking about an equilateral triangle and how we use it in geometry. Let's go ahead and let's get started. So an equilateral triangle is a triangle that has 3 equal sides and 3 equal angles, meaning all the sides have the same length, they're all congruent, and all the angles inside have the same exact measurement, they are also congruent. And the idea behind this is if we can use one to kind of prove the other. So if they tell me that, hey, your triangle has 3 equal sides, then I know all the angles on the inside have to be equal to each other. Or if I'm given that all angles on the inside are equal to each other, then I know in turn that all the sides have to have the same length. So here's an example of an equilateral triangle. All the side lengths are congruent, but we also know that all of these angles C, B, and angle A, all of them are also equal. It's like the perfect triangle, okay? So let's go ahead and let's look at a couple problems where we can use this. All right. So we're going to use this idea to help us find the angle measure in the figure. Most of the times when we're working with equilateral triangles, it's not really about finding a side that has the same length, mainly because, I mean, if you find one, you know what the other two are, okay? So it wants us to find the angle measure in each figure. So there's 2 angles that they're looking for. The first one is angle PNO, so they want this angle here in green. So they want this angle. And the measurement of angle NOP, so we'll do that one in blue. NOP, so they want this angle here on the inside. So these are the 2 angles that they want. One thing to note about this problem, okay, is that we have here an equilateral triangle, MPN, that's a equilateral triangle. But then we have right next to it an isosceles triangle. How do I know this is an isosceles triangle? Well, because it has 2 sides that are the same length. These 2 sides are the same length, which means that's an isosceles triangle. Now, also, that would also tell me that this angle is congruent to that angle. Okay, so let's go ahead and let's figure out how can I find angle PNO. Well, because we have an equilateral triangle, one thing that we do know as well is that all these angles on the inside have to be 60 degrees. That is another property about equilateral triangles. If all the angles inside a triangle have to add up to 180, and if all the angles are the same, the only way that that's possible is if that they're all 60 degrees. Because 60 plus 60 plus 60 is 180. This is the only way this can be true. Now the way we solve this one for angle PNO is we've covered a theorem in the past called the triangle exterior angle theorem. And that's exactly what we have here. Angle PNO, this angle in the green, is an exterior angle theorem to our equilateral triangle, which means that this angle is going to equal these 2 added together. So it equals 60 degrees plus 60 degrees, which is just 120. So now I know that this angle on the inside is 120 degrees. And again, this is done by the triangle exterior angle theorem. And then this is where the idea of an isosceles triangle comes into play, because I know that this interior of this angle also has to equal, all those angles on the inside have to equal to 180 as well. And I know that these 2 angles are equal to each other. Those 2 angles in the blue, those are congruent because this is an isosceles triangle. Okay? So I know that 120 plus these 2 angles has to equal 180. So 120. So here's how we do this. We're going to call this angle X, but this also has the measurement of X. So we know that 120 plus X has to equal 180. I can subtract the 120 from each side. And I can also combine these 2 X's. So that'll leave me with 2x equals 60. I can then divide by 2 on each side, and that'll get me my final answer, which is x equals 30, which means both of those angles have to be 30 degrees. If you're a little bit confused about the isosceles triangle, you might want to watch the video I did on isosceles triangles and why I was allowed to do that. But essentially, we know that NOP would be 30 degrees, PNO would be 120 degrees by using properties of equilateral triangles and isosceles triangles. So hopefully now you feel like you understand what an equilateral triangle is and how we can use some of its properties to help us find different angles, different side lengths, or whatever they ask us to in math class. Again, if you felt kind of lost on that isosceles triangle part, you might want to go back and watch that video. But if not, stay tuned for what's coming next. I'm sure you'll enjoy it, and I hope that you all continue to learn.